So we're going to go over the extra practice page on page 71 for our textbook. And this is section 1-7, chapter 1, section 7. And what we're looking at here is trying to calculate what the constant rate of change would be. So in this particular situation for number 11, we have an increase in minutes of 500. And we see that this pattern continues. So all instances here are increasing by the same amount of 500. We also have an increase in the cost, and the cost is labeled as dollars, and the increase here is by $15. So we're increasing by $15, and again, it's $15 for each instance. So we do have a constant increase both in the cost and in the minutes. Now, to find the constant rate of change, we want to figure out what is the cost per 1 minute. So if I am writing this out, my initial rate is going to show me that I have $15 for 500 minutes. Now, that's a really, really big rate, especially if we're trying to figure out what happens when we divide or when we find out what it is per 1 minute. So what we actually do here is we realize that this is nothing more than a division problem. So we're going to go ahead and we're going to divide. So we would take 15. Okay, so we take 15 and we're going to divide that by 500. And we know, hey, while 500 doesn't go into 1, it doesn't go into 15, it doesn't even go into 150. So we're going to put our placeholder there. But it will go into 1,500, and it goes into 1,500 3 times. 3 times 500 is 1,500. So when we subtract, we end up with no remainder. So in reality, what this is saying is that we are being charged essentially 3 cents for every single minute. Okay, so that is how we would find our initial rate. Now, from there, what we're trying to do is we're trying to, or I guess the next problem, sorry, not from there, but in the next problem, we are going to use a graph. Now, this graph for us is giving us specific points. So they showed us that we have 0, 0, meaning it starts at the origin. Remember, that is huge when we're trying to find out if they are proportional. All proportional graphs must start at the origin. And it is increasing at a constant rate. And I know this because it's a straight line. So in order to be a straight line, it has to have a constant rate. And they've already labeled for us the different amounts of increase, both in the vertical or the y-axis and in the horizontal or the x-axis. So what we're looking for here is it says use the graph to find the constant rate of change, then explain what the point 0, 0 and 672 mean. Well, before we can even get to this, we have to find that constant rate of change. And the constant rate of change is going to be the change in the y value over the change in the x value. So the y value very nicely increases at a rate, and they labeled it for us, of 72. So I can say that this is going to be 72, and our label here is pages. Those are pages. Just going to put a PG here. Now, the horizontal or the change in x is 6 minutes. So we have 6 minutes. And what we're going to find here is that if we divide, 72 divided by 6 is going to be 12. That is 12 pages per 1 minute, or 12 pages per minute. Now, that's our constant rate of change. And what that means is that for every minute, we are going to have 12 pages printed. So now let's go back to this next part of the question of 0, 0. 0, 0 for us would represent that no pages have been printed. It also has been 0 minutes. So if you think about it, if we haven't had any time go by, no pages could have been printed yet. Likewise, if we go to the point of 672, we would say that 6 minutes have gone by and 72 pages have been printed. Now, if we go all the way up, we would say that up here we have 216 pages for 18 minutes, or in 18 minutes, we could print 216 pages. Okay? So now let's jump down and we're going to go over number 13. Whoops, sorry about that. It says that Ramona and Josh earned money by babysitting. The amounts earned for one evening are shown in the table in the graph. Who charged more per hour? Now, in order to charge more per hour, that means that they have a larger constant rate or a larger rate. So again, what we're going to do is anytime we have a table, we're just going to find the change here. So the change in time is for 1 hour. And for 1 hour, 18 to 27 increases by 9. So right away, if we divide, we have $9 per 1 hour. So $9 per hour. Let's double check that though. From 3 to 4 is 1, and from 27 to 36 is also 9, and that stays the same. So it's $9 per hour all the way through. Now for Josh's earnings, we notice that it starts at 0, 0, so we know it's proportional because it's going in a straight line. And what we can do for Josh is we can again find this delta y, or the change in the y-axis over the change in the x-axis. So from one point to the next, we're going to make our little triangle here, and it goes up 10. So that means a change in the y-axis of 10. And 10, the y-axis is dollars. And the x-axis changes from 0 to 1, or by 1, and that's hours. So per 1 hour. So we have Ramona, who is charging $9 per hour, and Josh is charging $10 per hour. Simple math, we know that 10 is larger than 9. So therefore, who charged more per hour? We would have to say that it's going to be Josh. Hopefully this helps you guys with a little bit of these problems and with a little bit of an understanding of how the constant rate of change works. Remember, look at the labels. Number 11, it wouldn't really make sense for us to say how many minutes per dollar. Usually we want to know how much is it going to cost per minute. All right, pages printed per minute. All right, and then for the last one, obviously, dollars per hour when we're charging a rate. We're not going to figure out how many hours per dollar. Okay, so the labels help us remember which one's going to go on top. And if when in doubt, just remember delta y over delta x. Change in y, change in the vertical over the change in the horizontal.